One thing that attackers are always trying to do is increase the effectiveness of their denial of service attacks. And one way they can do that is to try and amplify them. So how can they make the attack larger such that it has a greater effect on the target? One way that has been very popular in the past to amplify this attack is to use DNS. And in fact, this approach you'll sometimes see referred to as DNS reflection as well. And the reason it can be called reflection will make sense in just a moment. So let's walk through how it works. We have an attacker and they're going to make a small spoofed DNS request. Now DNS requests go out over UDP, which is a fire and forget protocol. You send off the request and you hope it makes its destination. There's no error checking or resiliency like in TCP. As we also just saw with the UDP and ICMP layer 4 attacks, you can also spoof the source IP address in the request header. So what we're actually getting here is an attacker making a small query to a DNS server and they're spoofing the IP address of the target they want to take down. Now very specifically what they're trying to do here is make a DNS query which is small but results in a large response. So for example, the attacker may request all the DNS records for a particular zone. That would create a large amplified response which is then sent to the target machine, the one whose IP address was spoofed in the original DNS request. This again also hides the original source of the attack. As far as the target is concerned, all of these requests are originating from the DNS server. And in fact, many times we've seen cases where the victim has gotten in touch with the DNS provider and said, hey, can you guys stop DOSing me? And of course, the DNS server provider is not the culprit. However, this is usually possible because there are open relays, or in other words, DNS servers which are accessible by anyone. So they do have some level of accountability here. I've represented this pretty simply. A single attacker, a single DNS server. But what happens when we further amplify this by the attacker controlling a botnet? Let's go and look at that now. Let's scale up this DNS amplification attack. So we'll take our attacker, and the attacker might have a mere 1 megabit per second connection. A very, very small connection. But it doesn't matter because that is enough to then communicate with their zombie machines. So remember, these are the machines that are in the botnet. Now each one of these machines has a 1 gigabit connection. So for example, they could be servers that the attacker is controlling. That results in them being able to send requests out at 3 gigabits a second. Now they're going to use DNS amplification, so each one of these machines is now communicating at 1 gigabit a second, which gives a total of 3, and they're communicating to a whole bunch of different DNS resolvers. And these resolvers are going to be used as amplifiers. And the factor they're going to amplify at is a factor of 10. Now what this means is a request can come in that's very small, say it's 100 bytes, but the response is very large. A factor of 10 would mean it's going to be 1,000 bytes. Now because we've got that factor of 10, and you've got 9 machines here, all receiving 1 gigabit a second, the amplification is going to result in a 90 gigabit a second attack against the target. So there's the amplification in play. That 1 megabit from the attacker turns into 3 gigabits from the zombies, turns into 90 gigabits as a result of DNS amplification. This style of attack is enormously effective because the attacker just keeps leveraging. They leverage by having the botnet, and then they leverage again by using these open DNS resolvers that can return a much larger response than the request which came into them. So that's a really good example of what certainly in the past has been a very common amplification attack. There are far fewer open DNS resolvers available today, but there are other forms of amplification attack as well. Let's go and take a look at those. A few other ways that a DOS can be amplified. One is SNMP, the Simple Network Management Protocol. And in fact, we've seen SNMP used to great effect in the past. In fact, amplification up to a factor of 650 times. So that 10 bytes going in can result in 6,500 bytes coming back out the other end directed to the target system. Now, fortunately, there aren't a lot of those open on the web today. They tend to be more constrained to internal networks. Another protocol used in amplification attacks is NTP, the Network Time Protocol. Now, these can return very large results via the monlist command. And what this command can do is return the addresses of up to the last 600 machines that the NTP server interacted with. So that can mean there's a much larger response than the request that went into it. Now, NTP, like SNMP, also runs over UDP, and the source IP address can be spoofed. So that's the underlying construct that all of these amplification attacks are taking advantage of, making sure that that large response is going to somewhere other than where the request came in from. And in the case of NTP, that amplification factor can be up to a couple of hundred times. So perhaps not quite as big as SNMP, but still a massive factor on top of the size of the request that came in. Yet another form of amplification attack is using the SSDP protocol, the Simple Service Discovery Protocol. And in this case, SSDP is used for the advertisement and discovery of network services. And what we've seen in the past is attackers querying home devices with UPnP enabled, which can then result in responses which are much larger than the incoming request. So that same amplification pattern again. And like SNMP and NTP, SSDP also runs over UDP, which of course can have forged source IP address headers. So in that regard, they're all very similar, even though the protocols are designed to do quite different things. Amplification attacks are enormously effective because of the leverage they give the attacker. But they do rely on these protocols being openly accessible and vulnerable to forged source IP addresses. We'll look at some of the ways that we can mitigate against these attacks when we get to the last module of the course. For now though, let's move on and look at a very different style of DOS attack, and that's peer-to-peer attacks.